2024 A-Level Combined Mathematics Paper 1, Part A, question number 8. This question has to do with straight lines in the coordinate plane. The question says, find the equations of the two straight lines passing through the point A, which is given by negative 1, 2, and having a perpendicular distance of 1 from the origin. Now here we can see we need to find two straight lines, and we are only given two bits of information to find them. The first bit of information is that both of these straight lines pass through the point A, which is negative 1, 2, and the second bit of information is that both of these straight lines have a perpendicular distance of 1 from the origin, as in the 0, 0 point. Now what we need to do here is to use these two bits of information separately to derive two equations on these two straight lines, which we can then use in order to find the final two straight lines and then solve the problem. So to start off, if we take a look at the first bit of information, we know that any line passing through a point, let's say x0, y0, is going to be of the form p times x minus x0 plus q times y minus y0 equals 0. And we can prove that this is going to be the case, and this line, no matter what p and q are, no matter what real numbers p and q are, this straight line is always going to pass through the point x0, y0 by simply substituting x equals x0 and y equals y0 into this equation. So if we do that, we can see we're going to get p times, and then here we're going to have x0 minus x0, which is 0. So we're going to get p times 0, which is always going to be 0 no matter what p is. And similarly, the second term is going to be q times y0 minus y0, which is going to be 0. So we're going to have q times 0, which is going to be equal to 0 no matter what q is. So therefore, no matter what p and q are, when we substitute x0, y0 into this equation, we are always going to get 0 on here and 0 on here. So we're going to get 0 plus 0, which is 0. And therefore, the left hand side is 0 and the right hand side is also 0, which means that no matter what, the point x0, y0 is going to substitute into this line and satisfy it. So therefore, if we apply that in this particular situation and consider x0, y0 to be negative 1, 2, we can see any line passing through the point negative 1, 2 is going to be of the form, and we can write the form p times x minus x0, which is going to be x minus negative 1, which is x plus 1. So x plus 1 plus, and then q times y minus y0, which in this case y0 is equal to 2, so we're going to have y minus 2, so we're going to have q times y minus 2 equal to 0. When we have to say here where p, q are elements of the real numbers. Now, in addition to this condition where both of p and q are elements of the real numbers, we need to have another condition, and this condition is really a caveat, because if you consider p and q both being equal to 0 at the same time, we're going to have 0 here and 0 here, and therefore no matter what x is and no matter what y is, we're going to have some value times 0 plus some value times 0, which means that no matter what x and y are, we're going to have 0 here, and therefore this equation is going to be satisfied no matter what x and y are. Now the physical interpretation for this is that every single point in the coordinate plane would satisfy the equation p times x plus 1 plus q times y minus 2 equals 0. Due to this, we cannot have p and q being equal to 0 at the same time. Now we can express this by saying p squared plus q squared not equal to 0 at the same time, because we can see since p and q are elements of the real numbers, the only way that p squared plus q squared is equal to 0 is if p and q are both equal to 0 at the same time. Therefore, if we say p squared plus q squared not equal to 0, it is basically identical to saying p and q are both not equal to 0 at the same exact time. One of them can be 0, but if one of them is 0, the other one cannot be 0. Now considering that, we can write this as equation number 1, saying that our lines must be of the form p times x plus 1 plus q times y minus 2 equals 0, where p and q are similar to the real numbers and p squared plus q squared is not equal to 0. Now, if we then consider the second bit of information, we can see the second bit of information says the perpendicular distance of the straight lines is 1 from the origin. Now, as we know, if we have any straight line of the form ax plus by plus c equals 0, then if we consider an external point h comma k, we are going to have the perpendicular distance d from this straight line to the point h comma k being equal to the modulus of ah plus bk plus c divided by the square root of a squared plus b squared, provided of course a squared plus b squared is not equal to 0. Now we can see we could apply this equation to this particular situation by substituting the perpendicular distance d for 1 and also substituting the points h comma k for the origin, which is 0 comma 0. So basically substituting h equals 0 and k equals 0. Now furthermore we can see in this equation we don't have a c explicitly. Instead, if we want the c, what we'll have to do is to multiply this thing through, and simplify it down. And if we simplify it down, we can see we're going to get p times x, so px, q times y, so qy, so px plus qy, and then the constant term is going to be p times 1 plus q times negative 2, so p minus 2q equals 0. So therefore, the c that we have to substitute into this expression here is going to be p minus 2q. Now if we use that and we do the substitution, what we're going to get is that if the above line has perpendicular distance of 1 from the origin, which is the 0 comma 0 point, we can say therefore the perpendicular distance, which is 1, must be equal to the modulus of ah plus bk plus c, which is in this case going to be a, which is p, times h, which is 0, plus b, which is q, since that's the coefficient of y, so q, times k, which is again 0, plus the constant c, which as we discussed is going to be equal to p minus 2q, divided by the square root of a squared plus b squared, which in this case a, which is the coefficient of x, is p, and b, which is the coefficient of y, is q. So therefore square root of p squared plus q squared. Now from this we can see this term becomes 0, this term becomes 0, and we are left with p minus 2q's modulus divided by square root of p squared plus q squared equal to 1. Now if we rearrange this by taking this expression to the left hand side, we're going to get modulus of p minus 2q being equal to square root of p squared plus q squared. Now in this case we can see if we square both sides, which is totally fine, we are going to get on the left hand side modulus of p minus 2q squared, and since the modulus squared is same as the original value squared, since then we're going to be positive, we can write that this is just going to be equal to p minus 2q squared, which is going to be p squared minus 4pq plus 4q squared, and on the right hand side the square of the square root of p squared plus q squared is simply going to be equal to p squared plus q squared. Now here we can see if we cancel out the p squared from both sides and we take one of these to one side by taking this q squared here and write this as 3q squared by subtracting 1q squared, we're going to get 3q squared minus 4pq equal to 0, and we can see if we factor out a q, we're going to get q times 3q minus 4p equals 0. Now we can see that there are two cases that we could have here. In order for this equation to be satisfied, we could either have q being equal to 0 or 3q minus 4p being equal to 0. So we can see therefore q is equal to 0, or we could have 3q being equal to 4p, or 3p minus 4, so 3q minus 4p being equal to 0. So I'm going to write that we can have p being equal to 3q divided by 4. So it's either q equals 0 or p equals 3q over 4. Now considering the first case, we can see if we substitute q equals 0 into this expression, equation number 1, like this, if we do equation number 1, we're going to get either q equals 0, which means we're either going to get p times x plus 1 plus 0 equals 0. So we're going to get p times x plus 1 equals 0, or if we have this situation, we can substitute p for 3q over 4 and get 3q over 4 times x plus 1 plus q times y minus 2 equals 0. So therefore we could get 3q over 4 times x plus 1, and then plus q times y minus 2 plus q times y minus 2 equals 0. Now in this case we can see, since q is equal to 0 in the first case, and since we know that p and q cannot both be equal to 0 in the second case, p is not equal to 0. So therefore we can divide both sides by p and say that we are going to get x plus 1 equal to 0, and we have to say here, because p not equal to 0, as p squared plus q squared not equal to 0. And that's the justification that we need to say that p is not equal to 0, and therefore we can divide both sides by p. So therefore, one of the equations is x plus 1 equals 0, or we could say x equal to negative 1. So that is one of our lines. Now considering the second line is going to be this line right here, and we can see we have q here and q here. Now, before we divide, we need to make the observation that p is equal to 3q over 4. And therefore, if q was equal to 0, we can see p would also be equal to 0. And since that's impossible, since p squared plus q squared is not equal to 0, and therefore p and q cannot both be equal to 0 at the same time, q cannot be equal to 0. Therefore, we can simplify this down to 3 over 4 x plus 3 over 4 plus y minus 2 equals 0, and we need to justify this by saying that p squared plus q squared not equal to 0, and therefore q not equal to 0. So we can say here, because q not equal to 0, as, and once again I'll write the reason that p squared plus q squared not equal to 0. And now that we've written the reason, we are justified in writing this, and we can see we could simplify this down, and we can do so by multiplying everything by 4. If we do so, we're going to get 3x plus 3 plus 4y minus 8, since 4 times negative 2 is minus 8. And the plus 3 and minus 8 gives minus 5, and therefore we could write this as being equal to 3x plus 4y minus 5 equals 0. And therefore that is our second line. So with this, we have found our first line, which is x equals negative 1. There's no y components here, it's just x equals negative 1, which means that this first line is just a vertical line like this. And we found our second line, which is 3x plus 4y minus 5 equals 0. And with that, we've completed the question. Now finally, let's consider the marks awarded for this question. So in this question, you have 2 bits of information to use. When you use the first bit of information and say that any line passing through negative 1, 2 is of the form p times x plus 1 plus q times y minus 2 equals 0, where p and q element are the real numbers, and p squared plus q squared not equal to 0, you get 5 marks for that. When you then use the second bit of information, which says that the perpendicular distance is 1 from the origin, and you write down this expression right here, or you simplify it to get this expression right here, writing that expression down gets you another 5 marks. Now when you simplify that expression down and you get to this point, and then you realize that this means that there are 2 possibilities, either q is equal to 0 like this, or p is equal to 3q over 4. You could say 3q is equal to 4p, or you could say 3q minus 4p equals 0. Either of them, when you identify that there are 2 solutions and write them with an or like this, you get 5 marks. Now after this, when you individually use each of these cases and you simplify them down with the relevant substitutions, and you write here p not equal to 0 as p squared plus q squared not equal to 0, and get x equals negative 1 as one of the possible lines, you get 5 marks for that. Similarly, when you use the other case, simplify down, use the relevant substitutions, and then say q not equal to 0 as p squared plus q squared is not equal to 0, and you get the final answer of 3x plus 4y minus 5 equals 0, you get another 5 marks for that. So that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in comments down below. Thank you for watching, and goodbye.